Good morning. So let me explain the project, both 6 bus system and 30. I have done both systems, and MATLAB files already sent to your email. So let me explain 6 bus system, and uh, for 30 bus system it's exactly the same procedure. Just you have to there is an change of line and load data. So here is the main file. Main file is redirecting into the PSO file. Okay, so here is the PSO file, and there are two decision variables are chosen, and one is size, that is minimum 500 minus 500 to plus 500, and the location is chosen between 2 to 6, and in case of 30 it will be from 2 to 30. So you can even change that the location decision variable. Okay, maximum iteration 100, population chosen to be 40. These are the PSO parameters, velocity parameters, and inertia weight. Based on these parameters, velocity of the uh, swarms are affected. And here is the initialization part for the PSO algorithm. Position cost. Position means the size and location for FACTS device, and cost means after placing the FACTS device into the system, the resultant power loss. So that power loss will be considered as cost. Velocity will be the velocity of the swarms, and here is the best position, best size and location for facts, and this is the best possible cost against that that particular size and location of facts. Okay, so there will be different costs based on different location and size of facts that were be decided by the PSO, and then we have to compare all with each other, and that will be the best cost possible. Okay, so initially it's considered to be infinite, and here is the let me click here, left click here and click on, so let me click on step, and now I can choose copy this and let me paste. So at this time the size for facts is chosen to be -488, and between fifth at the fifth location. Okay, and at this point we are going into the load flow file. So load flow file is the main file. Okay, okay, the above chosen size and location for facts are going into the load flow file. So here you can see that exactly same data are now we transferring into this one. Okay, so let me click on continue one more. Okay, okay, and now this is the second time, and now let me click on step, and now you can see that we have different number, so different size and different location for facts. In this way we have to for each iteration or for each population, the size and location for facts will be the different. So against that we have to find the best possible size and location of facts. And here is the line and load data. Okay, this is the resistance, reactance, and tap ratio, and other factors. Generation, this is the load, voltage magnitude, this is the load of the bus system. Okay, and here from here getting data from the line and load data files. Okay, and I mean line data 6 file, line data 6 column. So this one is the tab, and that will be considered as A, and X will be the reactance that is taken from line data 4th column. So this one. So in this way, getting data from that, and then admittance of the branch and impedance of the branch. Okay, and here is the Y bus matrix formation in so the load flow method used here is Newton-Raphson method, and in Newton-Raphson method we have to first create Y bus matrix, and then Y bus matrix is related to Jacobian matrix, and then in this way we find the power losses, voltage profile, line currents, and or line losses, and all other parameters which are linked to the load flow analysis. Okay, so here is the formation of the bus matrix based on the available buses. Okay, so here is the initialization of Y-bus or Y-bus creation. So let me click here and click on continue. So at this moment, when I here you can see we have 6 rows and 6 columns, and everything is 0. And after this, getting data from bus to bus, and then considering Y, here there is a difference. Capital Y is Y bus matrix, and this one is representing the admittance of the branch. Okay, so let me after calculating each and everything this table, now let me move my cursor to the Y, and now this data is updated. Okay, so previously we have Y bus, initially at this time we have 0, and from subtracting the existing value with the admittance of branch, and we have now updated Y bus. Okay, and again there is a parameter to update the Y bus, and after that, here considering the bus type, and this is the here you can see that PQ bus, PV, and slack bus. So based on your consideration, you can even change the, let me show you the type. So here we have type, and bus data second column is the type. Bus data second, so this is the type which is used here. So the other parameters which we have left here are now considered here in this case. So type is considered, the load of the 6 bus system is considered here, bus data, the reference voltages are considered PQ, and sorry, PG, and QG are considered here, PL and QL are considered here, and types are considered here. So here main loop for Newton-Raphson load flow is starts. Okay, so let me explain this line. So this is the QDG code, and this is here we are getting our QDG, that is minus 184 and 3, and now we are putting that power of FACTS device, dividing it by the grid capacity, or making it to the per unit. So putting the FACTS power which we considered from the PSO is now, so the power of FACTS which we have choose from PSO are now uh, going into our system by this line. So at this point we are putting our FACTS device power. Okay, and this the 2 means the location and 1 means first so putting it at the right location, third location, and what will be the power of its size will be divided by the BMVA. That is actually when you will click on it, and then it will be here, it's 100. Okay, and then there is a main loop of Newton-Raphson load flow. So if the while it will be so this is the convergence. Okay, so we have to get here the tall more than 1 e raised power minus 5. So we are looking for a real number. Sometime we are getting uh, numbers in e raised power minus 7, minus 8, a very low number, and that's not. It means that we are not getting into the convergence of our program. So that's why we have to run this up to we are getting a positive number, a good number, not a minus number or infinite or something. Okay, so here is the P, and again let me click here. Okay, at this point we have 0 at our P and then Q at 0. So previously it will be QL reactive load and PG were the real generation. Okay, and now there is a calculation for P and Q, and this is the part of the load flow, and then there is a verification of the limit violation of the reactive power. Okay, and here is the formation of the Jacobian matrix. Okay, and now we considered about J1, J2, J3, and J4. So these are the parts of the, so let me here, let me construct. Okay, so now here you can see that the Jacobian matrix is done, and based on this matrix we can find the voltage, magnitude, current, and all other parameters. Okay, so here finding out the P and Q in the final states, and then here is the load flow solution, and after that at this point we have find the, let me click on continue. Okay, so at this point we have SLT, and so this is the 118.45. So this is the losses by putting facts at a specific position. So this is the 118.45 kilowatts, the losses against that pair of size and location of facts. So let me click on run once again. Okay, and now let me check how much this time. So this time 115.17, better from last try. And let me check the QDG, and now QDG is previously it were minus 1183 and now minus 385. So in this way it's finding the best losses. Okay, so this is the part done here, and then we have to find the best position. Okay, let me click here and click on continue. Okay, okay, so let me show you the particle position. Here you can also check by this one. Just open it, particle, and then up to now position and the cost. Up to now there are two values evaluated, and this is the third pair which we get now, but this is not updated up to now. Let me click on few times. Okay, let me open the particle. Okay, so these are all entries are updated. Okay, and let me check the best here. Here this is the personal best, and let me check this is the minus 4885 and 6.07, not the best. This is the triple 1.335. Okay, so these are all personal bests, so later we have to compare them with each other, and the best possible number we will consider that as the global best. Okay, so here will be the comparison for the global best, and then there is a PSO main loop where velocity and C1 inertia and other factors are included, and then again the particle eye position is updated. After updating particle eye position, the size of facts and location, then we are going into the load flow uh, load flow this part, and then we will get again the best cost, the cost against each pair of size and location, and then we will again find the best possible location and size for our facts, and finally here we will find the best possible solution, and then the global best position will be putting into the result part. Okay, and here the getting let me click continue this video. So against each iteration the best possible values are displayed here. Okay, so here we have minus 253 the size, and 6 will be the location, and now we are getting into the result file. Okay, so let me putting it. So the previous load flow file is for just evaluation of best possible fact size location, and this result will be after getting the best locations, best possible combination, we have to put that into the result file and load flow both are same. Result file is just for the printing the results, uh, the best combination which we get from the load flow 6, and then we have to put that one into the result file. So let me click on result, let me click on step. Okay, so exactly same which we have seen previously, minus 253, and now it's same thing, and now we have to put that one here, and after that here is the printing of each and everything. Okay, so here I have previously it were in degree, then I convert it into the radian, and your other requirement was to uh, without fact 1 to 2 and 2 to 1, I have updated that one too, and then here let me click on continue. Okay, so it's done. So here's a 2 to 1 and 1 to 2 and 3 to 6 and 6 to 3 2, and there's losses. So that's it. Hopefully it will helps you a lot for your understanding about facts. So thanks for watching, and if you have any other query or question, you can send me a message on WhatsApp, and I will respond there accordingly. Okay, thanks for watching. See you.